this video, we'll be solving past paper questions on geometric progressions. Number 7. The second and third terms of a GP are 10 and 8 respectively. Find the sum to infinity. Okay, so our formula for nth term is un is equal to ai to the n minus 1. In this case, we're given the second term, u2, and we can write that as ar to the power n minus 1, which is 2 minus 1. So u2 is equal to ar, and we're given that this is equal to 10. And then we also have u3. u3 is equal to ar squared, and in this case it's equal to 8. And using this information, they want us to find the sum to infinity. Sum to infinity is equal to a over 1 minus r. So it means we first have to find a and r. So we have two equations in terms of a and r. That's ar equals 10 and ar squared is equal to 8. So let's start by finding r. So r is equal to ar squared over ar, which is 8 over 10. This means that our value for r is 4 over 5. And then now let's find a. So we have ar is equal to 10, which is a times 4 over 5 is equal to 10. And this becomes 10 times 5 over 4, which is 50 over 4. A is equal to 10 times 5 over 4, which is 25 over 2, or 12.5. 12.5. And now that we have a and r, we can find our sum to infinity, which is 12.5 over 1 minus 4 over 5. Punch this into the calculator. 12.5 over 1 minus 4 over 5, and this gives us 62.5. So the sum to infinity for this GP is 62.5, and that's our final answer. Let's move on to the next question. A GP is such that the third term is 1764 and the sum of the second and third term is 3444. Find the 50th term. So we're given the third term can be written as ar squared, and this is equal to 1764, and we're given the sum of the second and third terms. So that's the sum of u2 plus u3, and we're given that this is 3444. So what we can do is we can find the second term, since we know that our third term is 1764, and we know that the sum of the third term plus the second term is 3444. So we can say that 3444 minus 1764, this should give us the second term. So that's 3444 minus 1764, that gives us 1680. 1680. So we know that our second term u2 is equal to 1680, which can be written as ar is equal to 1680. And now we have two equations in terms of a and r, and we can evaluate our values for r and a. So to find r, we're going to say ar squared 1764 over ar, which is 1680, and this simplifies to give, let's punch that in the calculator, 1764 over 1680, that's 21 over 20, or 1.05, and then we need to find a. So we have ar is equal to 1680. This becomes a times 1.05 is equal to 1680. Divide both sides by 1.05, So that's 1680 divided by 1.05, and this gives us 1600. And now we can find the sum, or they want us to find the 50th term. So we can find the 50th term. The formula for nth term is ai to the n minus 1. So u50 is equal to 1600 times 1.05 to the power n, which is 50. 50 minus 1. Punch this into the calculator and you get 1600 times 1.05 to the power of 49. That gives us 17,474, which is 17,500, correct to 3 significant figures, and that's our final answer. Number 15. The first term of a geometric progression is cos theta, where theta is between 0 and half pi. A. For the case where the progression is geometric, the sum to infinity is 1 over cos theta. Sum to infinity is 1 over cos theta. Part I. Show that the second term is cos theta sine squared theta. So we know that our first term is cos theta, and we know that our sum to infinity is equal to 1 over cos theta. So we can write this as a over 1 minus r is equal to 1 over cos theta. And we can use this to find our r and therefore find our second term. So let's substitute a with cos theta here. That becomes cos theta over 1 minus r is equal to 1 over cos theta. We can cross multiply here and we get cos squared theta is equal to 1 minus r. So r must be equal to 1 minus cos squared theta. Using the identity, sine squared theta is identical to 1 minus cos squared theta. We can substitute 1 minus cos squared theta with sine squared theta. So our common ratio is sine squared theta. And now let's find the second term. So the formula for nth term is ai to the power n minus 1. So u2 is equal to ai to the power 1. And in this case, u2 is equal to a is cos theta and I is sine squared theta. And that's our final answer. Let's move on to part 2. Find the sum of the first 12 terms when theta is 1/3 pi, giving your answer correct to 4 significant figures. Okay, so we're given that theta is 1/3 pi, so that means a, which is cos theta, becomes a is equal to cos 1/3 pi. A is equal to, let's punch this into a calculator, make sure you're in radians. Cos of 1/3 pi, that's half, and then I is equal to sine squared theta. So I is equal to sine squared 1/3 pi. Let's punch this into a calculator. That's sine of 1 over 3 pi, and this is squared, which gives us 3/4. Okay, and we are required to find the sum of the first 12 terms. So we'll use the formula for sum of first n terms. That's a times 1 minus r to the power n over 1 minus r. So sum of the first 12 terms is equal to half times 1 minus r, which is 3/4 to the power n, which is 12. And this is divided by 1 minus 3/4. Therefore, the sum of the first 12 terms, punch this into your calculator, that's half times 1 minus 3 over 4 to the power 12, and this is all divided by 1 minus 3/4, and this gives us they want their answer correct to 4 significant figures, so our calculated display is 1.936647,296. So our final answer correct to 4 significant figures is 1.937. So that's it for this video. Thank you for watching. If you enjoyed it, please like and subscribe for more videos like this. Bye bye.